Let's start. A little bit about me. I have telecommunications engineering background. I always wanted to be closer to the end users. I started with Bluetooth applications and then worked in small companies doing smart locks and like these Apple tags. Before Apple tags, of course, there was this Be Safe buttons made in Finland. It didn't work. And then I worked in Suunto for 4 years. I did sports tracker and Suunto mobile application, and then also Suunto 7 Wear OS watch. Then I started Flutter in small startup companies. I had no idea about Flutter. I just wanted to do cross-platform, iOS and Android. Then they accepted me without knowing anything about it. In 6 months, I was really happy about Flutter. Then I started at Wolt as an Android developer, not Flutter developer. But luckily, we had a Flutter project so that it could work full-time. We started with 2 people at Wolt doing Flutter. Now we are 6. There was only 1 team responsible for Flutter application. Now 2 teams merged and 2 teams are doing Flutter application. So we are coming. And 2022, actually last week, I became the first Flutter GDE in Finland. But in this, we have very good experts as well. It's just recognized by Google Mine. And also today, I became the competence lead for Flutter at Wolt. So as you can imagine, I really love Flutter. But I want to start this talk before Flutter, because we really need to understand why Flutter emerged. We talked about UI kit, app kit, but there is also WebKit, right? iOS developers are familiar about it. How many people are familiar with WebKit? Yes. So WebKit is a browser engine developed by Apple, used in Safari, and it's a mandatory to use it in all iOS web browsers. And when Chrome started, it actually used WebKit as well. But Apple, Google, they are competing, and it's really difficult to add new features, work on the same project. And Chrome also had a different architecture. And as a result, in 2013, Chrome forked WebKit. And then, as Adam Barth, we will come to this person again in the next slides. He says that Chromium has a different multiprocess architecture, and it increases the complexity to make it work with WebKit. So it was very difficult to work with 2 teams. In 2013, WebKit was forked and became Blink. So what is in Blink? This DOM, HTML DOM, and CSS rendering engines, web IDL implementation. Most importantly, Skia is a 2D graphics engine, which makes calls to the GPU. These graphics libraries, OpenGL, Vulkan. And also Blink has this V8 JavaScript engine that makes the JavaScript run in browsers. Let's continue. Now I want to talk about Adam Barth and also Eric Seidel. They are actually the founders of Flutter. You should watch this video. I think it's a really historical video about Flutter. And they have this Rubber Duck Engineering YouTube channel. They are doing amazing videos about computer engineering, computer science. Like, subscribe to this channel. But when it's explained about Flutter, Adam Barth says that we are trying to go to grandma's house, but we have an aircraft carrier. It has everything: kitchen, dentist, nuclear reactor, and everything. So think about this. But we want to achieve simple things. We want to go to grandma's house. Let's take nuclear reactor and use the truck instead of an aircraft. So they said that they were experimenting because in this time, 2013, 2014, it was a time that mobile was emerging. And Google was behind, and they were experimenting because it was very difficult to get good experience with mobile web browsers. And the idea is that strip away all the web essentials of the web platforms. So what are these essential pieces of the web platform? Let's think about it. I'm going to give a few seconds. This goes slow. Yes. Okay, in 2013, they started this project Brava. And let's think about the essential parts of the web. One is universal app, which is browser that fetches the pure JavaScript code. And let's serialize this JavaScript code. Let's fetch it. And then, yeah, let's type an URL. And then let's fetch a JSON code. JavaScript code serialized as JSON. Another thing is that let's have the framework, which is in JavaScript, and build the web with DOM nodes and elements. This is, I'm talking about the project Bravo, by the way. So, but this time in the mobile, let's not build exactly the same way as web. So there won't be HTML parser. Just fetch it, the code as serialized JSON. Then run the JavaScript against OpenGL. So directly talk to the GPU. In web, there is this WebGL, but with mobile browser, directly talk to OpenGL and use these networking APIs and platform-specific APIs. And access the layer 3 and build the layer 3 by talking to GL. And do the composing by yourself. And don't really take the exact layout models from web, exactly not CSS float, because Adam Bart hates it. But anyway, important thing is that just start doing this. In 2013, make mobile web-friendly. I mean, browser-friendly or whatever. But just experiment and fail, and you become the expert but by just failing enough times. And in 2014, they started another project. They realized that parsing the HTML in mobile, it's really difficult. And the animation, having 60 frames per second animation is really difficult, this performance. So they approached with this stripping. They only removed constantly, every day, they removed like thousands of lines of code from the Blink, which is the rendering engine for Chrome. And then they had really good results by removing the complexities, that extra complexities that web brings. You are in mobile, so you don't need these extra complexities, but also just for experimenting, how fast can you get? They got rid of all the unnecessary complexities. And they removed these tree traversing CSS selectors. Someone was using CSS, someone was saying that, but as you might know that this using CSS selectors and traversing the tree, it's affecting performance a lot and causes slow layout. And we are really after 60 frames per second and 120 frames per second performance. So they got rid of the code from Blink and it was shrunk 52%. And then they went to their boss. We are really up to something. Give us budget. We will make a really good product. And then Eric and Adam, they left the Chrome team and they started Sky, the project Sky. And in 2014, Adam Bart had the first commit, which is the same repository of Flutter. So Flutter is actually not that new. You might think that it came recently, but the first commit of Flutter was made in 2014. So in 2015, they put these experiments in the mobile. So they were trying to get this mobile experiment. But you know, Chromium is a cross-platform toolkit. It runs on different platforms, Windows, Mac, desktop. And they use this something called Sky Shell. And it basically put the code as an APK to the Android. And it fetched the JavaScript code over the network. And they made demos. You can see here the first sky view. It is like a web view. And then this Dart app, it is fetched over network, and it was showing a material app. You can see this video on YouTube. It is really exciting. In 2015, they were iterating very quickly. They were getting rid of all this unnecessary stuff that comes with web. And then they were easily doing changes and iterating. But at some point, the web is, very tied to JavaScript. So they were not able to move fast because they were asking some changes from the Chromium team, and it took so much time. They were not happy with the cooperation. And then they were looking for some other solution, like what could be done other than JavaScript. And then there was another team at Wolt, at Google. Okay, there was another team at Google, which started with Chrome actually. And then in 2011, they announced structured programming language for web called Dart. And then they approached Dart team. In 2015, Dart team was looking for new places to go because they couldn't go to browsers, because the browsers needed to have Dart virtual machine to run Dart native code. Even Google Chrome didn't have this Dart native virtual machine. So they were looking for other options, how can get reach to more people. So it was kind of a win-win. And Flutter team was asking changes from the Dart team, and Dart team was bringing these changes very fast. So Ruby on Rail, without Rail, Ruby wouldn't be that popular. And without Android development, Kotlin would be such success. But again, the same effect that Dart had with Flutter. So it's totally a win-win. And Dart became more like a customized language for UI framework, because Dart was meant to be a structured language for web. But after cooperation with Flutter, it became a language for user interfaces. And then it scaled up after 2015. So there was this Sky Shell for Android. And with the really great minds behind Dart, they were easily, not easy, but they were very fast getting this compatibility with iOS. And then offline mode, they removed this Sky text that I showed in the previous slide. And they introduced widget tree, render tree. In web, it is just in time and there is virtual machine. But then with Dart team, they introduced this ahead of time compilation. So it was, everything was moving fast, and Dart was happy, Dart team was happy, Flutter team was happy. And then the Sky was renamed to Flutter in 2015. It is named to Flutter because it had free domain name. Google acquired just another company and killed it. And there was this domain name available, and Sky became Flutter. So this was the story. So now we understand what Flutter was trying to solve. But let's talk about the architecture of Flutter. Before the architecture, I also want to start with, is Flutter native? This is really controversial question. Mike, is Flutter native? Alessio, is Flutter native? Edinburgh says yes. Okay, I'll come back. Yes, that's the point. Anyway, in Android, okay, let's talk about Android. That's the question. Okay, in Android, the source code is first compiled to bytecode. It's a Java virtual machine. It's Android runtime. It was Dalvik before. Anyway, it is first compiled when you have this compilation. It's first compiled to bytecode. And then Android runtime performs this translation of bytecode to the machine code so that the machine understands it. In iOS, source code is first compiled to intermediary language. I can never say this, intermediary language, yes. And then LLVM generates the machine code. So in the end, what native is doing, producing machine code. Let's see. This is not working very well, but I need to show this maybe. Okay. Okay, So native applications drove the, no, this is not supposed to be the next. Okay, maybe yes. Okay, native applications draw the UI components on screen using libraries provided by the platform UI libraries. You know, iOS is not open source. Android is open source. So I was able to get the widget folder in Android's open source project, AOSP. You can see all the widgets there. So when you ship your application, you don't need to add this library. And if it is earlier version of iOS, you will see this dialog. And if it is newer version, you will see this. Because you ship your output, and this output uses the widgets, views, whatever they are, from the platform libraries. And this is what people call native. And these platform UI libraries, for example, in here, they use OpenGL Metal Vulkan, which communicates with the GPU that draws the pixels on the screen. Here, I wanted to just highlight this. The button here, for example, in the early version of Android is using this button from the API. Android operating system open source project. Anyway, well, Android has these also Jetpack libraries, which were earlier support libraries to make it more compatible for the earlier versions. But this is the idea. But is Flutter native? Now, that's the question again. But let's first understand what Dart does and what Dart team brought to the table for Flutter. So Dart team made first just-in-time compilation and ahead of time compilation for first mobile and desktop. And in the end of this compilation, what is produced is machine code, like under LLVM and ART produced. But for web, it is different story. It just compiles Dart to JavaScript. So Flutter, we talked about Chromium. Chromium had this 2D Skia. Flutter apps have this Skia in the Flutter engine. We will come back to this. So Flutter, instead of talking to system UI libraries, and system UI libraries talks to this GL, Flutter has this own rendering library that talks directly to the GL. Yes. And Skia in Flutter supports different backend. For example, for iOS, it supports Metal. For Android, it is GL, OpenGL, I think. So it generates, the application is shipped in a way that it generates, the application itself generates the instructions for GPU. Here, I added an example for our Flutter app. This is gonna be shown in entire Android APIs, Android minimum 23, I think we have. It will look the same, exactly the same. But we wanted to look more iOS-like, so we just changed, depending on the platform, we just changed the tabs, how the tabs look. So we talked about iOS 13, iOS 14 in the previous slides. When using Flutter, you don't care because you don't really rely on the platforms. When designers tell you something that, okay, this should look like this, it will look like in every Android API, in every iOS API. And I wanted to compare React Native here. Pedro is here, React Native developer with Flutter. So there are different ways of doing cross-platform development. For example, Ionic is a wrapper to web engine. And React Native actually is a wrapper around these system UI libraries, these OM widgets. And it accesses directly to the UI libraries. And there are packages that accesses to these libraries actually. So it's like you write the code with one high-level language, which is JavaScript, and there is a bridge, and there is this asynchronous communication, and it is translated to the n number of high-level language. What I mean, for example, you write with JavaScript, it talks to the Java code. In this previous slide, I showed you this free folder with Swift in the iOS libraries. If there is another platform, it will talk to that. So there is this kind of asynchronous communication, which might bring some performance issues. But I just want to add that React Native has a different architecture now, so it might be improved. But what Flutter does is that it skips these platform libraries. Instead, Flutter apps are shipped with Skia that comes with Chromium. Now we use Peller in the future, which is another variant of Skia. Skia is 2D library. So with Flutter, you have full control of the screen, and you can do pixel by pixel everything. So you don't call the components from the system UI libraries. Instead, you draw everything. You know how a material button looks like, and you can just draw it instead of getting it from the platform. And here, the good thing is that you have full control over the pixel, but also the performance now depends on two things. One is the clock rate, which is refresh rate. Device, for example, some iOS devices are 120 frames per second. So the performance depends on the device, but also your implementation, because some people come to me say that Flutter Web sucks, but are you sure you implemented it correctly? That's another question. Let's continue about architecture. So Flutter has this architecture. They are independent from each other, each replaceable, and dependent on the layer below. So you can have totally custom engine layer. You can take everything apart, and then, but it's not recommended by Flutter team to get everything done because engine is really heart of the Flutter. But you can remove entire framework layer because this engine also provides a Dart UI library where you can use it. It's a it's a low-level UI communication. So this actually it's in my next slide. This Flutter framework communicates with the engine through this Dart UI. It is again inside this layer. There is also another layer. So in the top, in the bottom, there is this foundation responsible for animation, painting, and gestures. And then upon that, there is rendering responsible for layout and painting, widgets for composition, and material and Cupertino libraries for adding a design language. But in the end, this framework is connected to the engine through Dart UI libraries. For example, when you are doing your game applications, you don't need this framework. You can just draw on canvas using Dart UI. And these material and Cupertino are the only design languages that come with the SDK. So in Android, for example, I'm not sure about, but when I was doing Android, I was adding these material libraries. But in Flutter, it's shipped. Cupertino is based on human interface guidelines. But at Wolt, actually, we have our own design language. So we are using another layer on top of material and Cupertino. We can say that it is Wolt language. Engine layer. It is the low-level implementation of the core APIs that this framework brings. For example, the graphics API, 2D Skia, comes from Chrome. I just want to mention it. There is another ongoing work with Flutter team. They are trying a different library because this was exactly taken from Chrome. So they are changing it, using it in Peller, and they are experimenting 3D drawing with this because Skia is only 2D. And then this text layout in the Flutter SDK that is shipped is using actually the text, the font from the drawing from Android open source project. So when you have your Flutter app, if you use iOS, the text is using Android text library. And then there is this Dart UI plugin architecture to communicate with the native code such as Bluetooth or, yeah, you can write native using platform channels. Yeah, and then there is this Dart virtual machine that is used for while debugging, and then compilation tools. And the embedder layer is the native part of Flutter because it's a host, and it's also an entry point, and it coordinates the communication with the operating system. It accesses the services like rendering, accessibility, input, and it manages the messaging event loop like threading. But web is different than other desktop mobile because web itself cannot web apps cannot directly communicate with the operating system because web apps are sandboxed in browser apps. So it requires some re-implementation of this engine. It's just the browser APIs, re-implementation in Dart. So this is how a Flutter project looks like. You see the lib, it is the entry point when you use pubspec YAML. It is looking for lib where your Flutter codes live in. But the rest of the folders are cross-platform, and they are the embedder. They are the host. They are the entry points. In your Flutter project, you will see these folders. Android, the main activity is the entry point. It just opens an activity, and the Flutter engine is warmed up, and it draws according to the code in the lib. Same in iOS, there is app delegate. Windows has main CPP, web index HTML, macOS app delegate, and Linux main CC. This is slow now. Okay, enough about architecture. Now let's talk about the views that Nick showed, and then we saw in the compose. We will talk about views, but we need to understand this concept with Flutter. It's called mahogany staircase. It's a representative of objects, like, okay, a tree of representative objects. We have a tree, and we construct parallel trees. And this is called mahogany staircase. Now let's see how it is called. So in Flutter, we have three objects. We do the diffings in these trees. And in Flutter, you will see this a lot. Everything is widgets. And similar to what Nick said, widgets are only configuration. It's like a JSON file, you can think. It just tells you how it should look like, but it has no implementation logic inside. It's just a recipe. Important thing is that, as Nick said, again, it's immutable. When you create a widget, you cannot update a property of it. You can just create a new one. And yeah, everything is widgets in Flutter. Even navigation is widget, even theme is widget, everything is widget. This is the motto of Flutter, you hear a lot. But anyway, mahogany staircase, a representative of objects in a different tree, element tree. So widget has no idea, but every widget has a corresponding element. And this element knows where the widget is, the size of the widget, all the information that is necessary about widgets, but widget doesn't know. So it delegates it to elements. And some elements and some widgets have render trees, which has the information about how to lay out, how to paint. Okay, when you are using Flutter, you are only working with widgets and elements. You are not really working with the render objects. As you can see here, wait, yeah. So here, widgets above it, we are in there. Rendering and below, they are low level, and we are only focusing on widgets. So widgets doesn't have information about where they are, about their size. But the framework provides the element as a build context, which is an interface that element implements. So it actually just limits what you can do with element, but you can still use it. Anyway, this was about the foundations of Flutter framework. But now let's focus on how, as I talked about pixel by pixel, and let's focus on how the pixels are drawn. So here there is a really nice illustration. There is a vsync signal that starts an animation, and it calls the build method. It's like a composing the widgets. It starts the composing, and then this is only in the pink part, you see that there is only build. And as Flutter developers, we are only building, and framework takes care of rendering, laying out, compositing bits, painting. Yeah, let's now discuss this a bit more. Flutter app developers, we have minimal roles when drawing pixel. I told you that we draw pixel by pixel, but it's not up, I mean, it's too much work. It should be a high level. So what we are doing is that we are composing a widget tree, like we are building, as Nick showed, it's tree. In the compose, we saw another tree. It's a widget tree. It has only configuration, and we give it to the framework. The framework creates the element tree, render tree, And when it's created, we just press a button saying that, okay, this needs to change, this UI needs to change. And it becomes 30. And in next build phase, it is updated. Okay. I would like to add the last one. So the framework, what is special with Flutter actually? What makes Flutter efficient is the algorithms, because everything is widget. There is like thousands of widgets when you are building a Flutter app. So there should be carefully designed algorithms and data structures to process large number of widgets so that you have 120 frames per second. Because Flutter is built with large number of widgets, yeah, it's using aggressive composition. It requires these algorithms. And I told you that widgets are immutable. So if a widget is immutable, and we have only like 16 milliseconds or 8 milliseconds when showing a new frame. So every frame we are showing a new widget. So it sounds like a wasteful to bring a widget at every frame. But despite how wasteful it sounds, the widget tree comes and goes. I told that it is dumb. It doesn't know. It just has a configuration like a JSON file. The actual thing is element and render object, and they are the expensive ones. So the widgets come and go at every frame, but the elements and render objects survive. And this is the critical success factor of Flutter. So Flutter, Nick also mentioned that cubic performance, but Flutter is initially linear performance, meaning that when you start the app, all the widgets are created, and from top to down, entire widget nodes, they are built. But after that, there is this 3D thing, and only some of them are built again. So the performance depends on less number of nodes, so it's sublinear. In the beginning, it's linear because the number of nodes will have number of builds. Yeah, and then from top to down, at every frame, there is one build path. So it's like one way. And the layout is also one way. The top to down, again, is very important because when you start building from the root to the bottom, the parents are responsible of diffing. Yes. And this update child is the element.update child. This is the actually summary of Flutter. If you want to learn Flutter, just read this method. And I asked this question to Nick, is Swift UI open source? Because if Flutter wasn't open source, I would not be able to give this talk today. This is how I learned Flutter. I read the source code of Flutter. I read how it works. It's amazingly documented. This is the update child. It's a summary. I'm not going to explain. But when you just simply read this method, you can understand how Flutter does the performance and how can you improve the performance. But I can show you. Let's see that this is a stateful widget that when you say that the state changed, it rebuilds all the subtree. So here stateful C is the subtree. You press it, the subtree starting from C, all the build methods are supposed to be called, but will it be called? Let's see. So old frame, new frame. There is this rendering pipeline. We are drawing frames. Let's see. Now from C to bottom, we are going to E. And I see that the widget type is widget E. In the new frame, it's widget E2. So they are the same frame, sorry, same widget. That means that I don't need to reinstantiate render object and element object. So it's from performance-wise, it's good. And then let's continue with, actually it's case 3 is here. An update, it updates. It's good for performance. Now let's check the case 5 here, widget Y. In the next frame, there is new widget. So I need to create and return a new element and render object, but there is nothing much to do. So we cannot save the performance. A widget needs to be created. It's fine. Oops, sorry. And in case 4, for example, let's see, Now there is a different widget type. So the runtime type of the widget is different. That means that I cannot reuse the element and render object, so it will be recreated. So it is not very good for performance. And in case one, the widgets are gone. The elementary, we are removing the unnecessary nodes from those elementary and render object tree. I think this is pretty much it. And this is the summary of, oh, I missed the case two. It's the most important one. Because in Flutter, in Dart, we have these constant constructors. That means that all the parameters, when you create a widget, if all the parameters are not runtime dependent, that I know that the widget from the previous frame, its reference is assigned at the compile time, and I don't need to check the build method. So constant widgets are good. So it will not going to check widget J because the traversing from top to down will end here. So using constant widgets, if you can, is good, but it's hard to get a constant widget because most of the widgets are runtime dependent because we have text and text is translated, and size. Sometimes there are some adjustments to make it pixel perfect. So yeah, it's hard to get constant widgets. We will come to that. Okay, I talked about the widget part, so building. So as Flutter developers, we are only responsible of composing widgets and calling the build method. But the below part now is responsible by the framework, and framework takes care of it. It takes care of layout. In Compose, I remember that there was this Compose layout and then paint. It's the same in Flutter. The framework, once you provide the widget tree and make sure which ones needs to be built, the framework takes care of laying out, painting, building the semantics, and sending the bits to engine. This is very fast. I'm going to say, this is what we are responsible as Flutter developers. So I press here, and then imagine that this is under a stateful widget. I press this one, and in the onPressed, I mark it as dirty. And then this widget will be dirty. When we start the rendering pipeline in the build phase, because in the entire part, only this one is dirty, it will call build methods on this one, this one. This won't go down because this is a constant widget, good for performance-wise, no need to go down. And here it will go down, and this is constant as well, down, down, yeah. So what happened is that I marked the widget when I clicked here as dirty, and it is added the list of dirty elements. And Flutter framework, when it starts the new frame, it calls the draw frame and then calls this update child method that I mentioned. And rendering pipeline, this layout and painting, I mentioned that. The pipeline owner is responsible of the rendering part. So it's about, again, this time we are not marking as needs built, but here, just a second. Yeah, here, and we are calling the update here. What can be different if the widget type is the same? For example, the size might be different. Then in the next frame, it will mark that the size is different. It needs to be laid out. So it's dirty. So in the same build phase, sorry, in the same rendering pipeline, it will call layout method for this render object. If the opacity is different in the next frame, during animation, for example, it will say that it needs painting. And then there might be some semantic changes as well. But that's it. This is the last one. I just want to go through the entire rendering pipeline. Here, let's say that widget F, we pressed it, and we called set state. It marks this subtree as dirty. And then it adds the list to the things that needs to be built. And then in the new frame, we start the building here. This widget has the same type. It needs to update only. So render object will be used, reused element will be reused. Here, there is a different one. So a new render object, new element needs to be added. Here we are removing the render object element from the nodes. Here we don't call down because this is the constant. And here we are adding a new one. And that's it. Thank you.